in this section is multiplying. Multiplying we kind of talked about yesterday for a second, the basics of it. Inside times the inside and outside times the outside. So if I have -3 square roots of 2 times 4 square roots of 5, I do -3 times 4 is -12. 2 times 5 is 10. And that gives me my answer on that one. But since you have multiplying, what we can also do with multiplying, we can multiply. We can do this property. What's this property called? Distributed property. I can distribute the square root of 2. Square root of 2 times x. All right, so the x is on the outside, the 2 is on the inside. So I just rewrite it like that. Square root of 2 times 5, they're both on the inside, so that becomes the square root of 10. If you have the distributed property, that means you can also have the...
Question.
Yes.
Why does the x go on the outside?
Because x is on the outside right here. It's not underneath the square root.
Oh, okay.
Does that make sense?
Mm-hmm.
If you have the distributed property, that means you can also FOIL. So square root of 5 times the square root of 3 would be the square root of 15. Square root of 5 times the square root of -2 would be, or negative square root of 2, negative square root of 10. 7 times the square root of 3 would be 7 square roots of 3. And the last one here, 7 times negative square root of 2 would be -7 square roots of 2. So then again, we know how to add now and subtract, so we check to see if we can combine any of those. So that's 15, 10, 3, and 2. So I cannot combine any of those. So we're going to use this multiplication and this FOIL in the next section. What if I have this right here? What does that mean?
FOIL.
I'm doing FOIL, right? I got to make sure I FOIL, so I do the square root of 2 minus 8 times the square root of 2 minus 8. So square root of 2 times the square root of 2. All right, we're going to talk about this for the next section. So square root of 2 times the square root of 2 would be the square root of 4, which is 2. So square root of 2 times the square root of 2 would be the square root of 4, which is 2. We'll talk about that after this problem. All right, so now what do? I got to do square root of 2 times -8, which is -8 square roots of 2. And then -8 times the square root of 2 would be -8 square roots of 2. And -8 times -8 would be positive 64. So if I add these up, this becomes -16 square roots of 2 plus 64. Well, then I can also put together this right here, right? Because that would be 66 minus 16 square roots of 2. All right, so let's go ahead and talk about that. If you multiply something times itself and they're both underneath the radical, what you'll end up getting is that same number without the radical. So what I mean by that is if I did square root of 7 times the square root of 7, that would be square root of 49, which is 7. So what happens here is since these are the same underneath, I just end up with that right there. So if I did the square root of 5x times the square root of 5x, what do you think I'd get? I just get 5x because I get what's underneath. If you wanted to work it out, 5 times 5 is 25, x times x is x squared. We'll then break that down and it equals 5x. But it will always, always, always work out like that. But if I do square root of 11x squared y times 11x squared y, since I'm doing that times itself, I will always just end up with that self times this radical. And if you think about it, since we're doing jailbreak, we're looking for parity, right? So here, if I multiply these together, I have a pair of 7, so it just pulls out. I have a pair of 5x's, so it pulls out. I have a pair of 11x squared y's, so it comes out. So I'm kind of, anytime you multiply something times itself underneath the radical goes away and you just have what's underneath. Let's see if there's any other multiplication ones. Let's do this. No, not that one. This one. All right, so here again it's FOIL. So 6 square roots of x times 8 square roots of x becomes what? 6 times 8 on the outside. Let me rewrite this. I need this bigger anyways. 6 square roots of x minus 6. 8 square roots of x plus 1. All right, so 6 square roots of x times 8 square roots of x. 6 times 8 would be 48. And then square root of x times square root of x would just be x. That's what we were just talking about. So the same thing, you just multiply it, cancels out. So now 6 square roots of x times 1 would be 6 square roots of x. Negative 6 times 8, so 6 is on the outside, 8's on the outside, so I multiply them together and get negative 48 square roots of x. Again, I wrote that in this column because I'm going to be able to add these together because they're the square root of x. So now negative 6 times 1 would be negative 6. See if we can't combine some stuff here. So I have 48x minus 42 square root of x minus 6. And that's all I can combine together. So that would be my answer. I guess we didn't do one with cube root, but it works the same way. Now wait though. When I multiply these cube root of a's times each other, when I multiply the cube root of a times the cube root of a, are they going to come out?
No.
No, because how many do I need to break out of jail? So I'm only going to have 1, 2 of those. So cube root of a times the cube root of a would be the cube root of a squared. A times a is a squared. I need at least 3 of those to come out. So that just stays like that. Cube root of a times 8 would be 8 cube roots of a. Negative 5 times the cube root of a would be negative 5 cube roots of a. And negative 5 times 40 would be negative 40. So combine some like terms here. We have the cube root of a squared plus 3 cube roots of a minus 40. So cube roots don't, when you're multiplying them, they don't work any different. Make sure when you're multiplying them, though, you don't do like 3 times 3, make that like the 9th root. Okay, so you're just doing a times a would be a squared. Let me look at one thing real quick before I go on to the next section.